so here we have the scenario where we're dealing with SAT scores, and it says that the scale was changed in 1995. Before then, they were based on a scale, set many years ago. And for math scores, the mean under the old scale, so the mean under the old scale in the 1990s for math scores was 477, and standard deviation for math scores was 110. And then in 2009, the mean for the math score was 515, and then the standard deviation was 116. So we have, two different distributions for SAT math scores. One, in the 1990s, and then one, in 2009 beyond, I guess. All right, so problem 1 or problem 2.9. Find the standardized Z-score for a student who scored 500 on the old SAT scale. Okay, so let's just go ahead, right? That the old SAT scores, before will be X. So the old math scores for let's say the 1990s, the 1990s. So the mean math score, so the mean of X, both right, was 470. And the standard deviation of X was 110. And we have that later, let's just say in 2009 and beyond. So in 2009, the mean math SAT score is 515. Let's write that as mu of y, y. 515, and standard deviation of y was 116. Just to distinguish it, X and Y. You don't have to, as long as you know what you're doing, but I like to be a little more clear. I don't think that even matters for this first one anyways, but anyways. So if we're gonna find the standardized Z-score for a student using the old SAT scale, we're gonna use these values. So let's remember that Z-score is equal to the X or observation value minus the mean over the standard deviation. So in this case, the X value here was 500. The mean was 470. And standard deviation is 110. We really just have 30 divided by 110. We have a Z-score of about 2.7 repeats. 0.27. And so your answer will be E for number 9. Now, problem 10, again, using the same information, we have that Gina took the SAT score in 1994 and scored 500. Her cousin Colleen took the SAT in 2013 and scored 530. So who did better on the exam, and how can you tell? So what you want to do is, calculate the Z-score for each individual based on their distribution. For Gina, it was the 1990s, and for Colleen, it was the 2009. So for Gina, her SAT score, was 500. But to find her Z-score, you're going to have that. Right. Let me just write it over here. Her Z-score would then be equal to, again, the observation value, X of 500, minus the mean during her, years, which was 470. So minus 470 over the standard deviation, sigma, in her case is 110. So her Z-score, the Z-score of Gina, would be then I guess the same one. Why? I don't know why I had to do this again. The same thing. 0.27. I didn't see that. Well, it's 0.27. We just calculate 0.27 repeating. Okay, now we want to compare to the Z-score of Colleen. Her Z-score is going to be calculated by using a mean of 515 and a standard deviation of 116. So her Z, the Z-score of Colleen will we're gonna have, you know, her observation. She scored 530, so her observation value is 530. Or you think her x being 530 minus the mean of her distribution, which is 515, over the standard deviation of her, her distribution over 116. So then we have essentially 15 divided by 116, and you have 0.13. About. And so you can see that even though that Colleen had a higher, score, raw score, 530, relatively speaking, she didn't score as high as Gina because she only scored 0.13 standard deviations above the mean, whereas Gina scored 0.27 standard deviations above the mean. So let's see which answer best matches this one. So we got A, B, C, and D. So Colleen, so first of all, it's not Colleen, so that's wrong. Colleen didn't work. Colleen, since Colleen didn't score higher, so those two are wrong. Wait, so Gina scored higher. So let's see, her standardized score is higher than Colleen's. And that's right. This is her standardized score. So it's gonna be C. Let's go with this through D and D just to make it clear. Gina, the standard deviation is bigger. It's not because of that. The standard deviation doesn't matter. And they did not do equally well. So the answer is C.